Welcome to WITS Education. The potential is constant throughout a given region of space. Is the electric field zero or non-zero in this region? Explain. Here it is given that the potential is constant. So from this given data that the potential is constant, we have to find whether the electric field is zero or non-zero in the region where potential is constant. As we know that the relation between electric field and electric potential is given by E is equal to minus delta V over delta R. Here E represents the electric field, delta V represents change in potential, and delta R is the distance between 2 points, and delta V is the change in potential between those 2 points having the separation delta R. According to this relation, the electric field is equal to the negative of the gradient of electric potential. The term delta V over delta R is known as gradient of electric potential. So electric field is equal to negative of the gradient of electric potential. The negative sign shows that the direction of electric field E is along the decreasing potential. Negative sign represents that the direction in which E decreases, the change in potential increases or the potential difference increases. By the given condition, that is V is equal to constant, potential is constant. So delta V is equal to change in potential. This will be equal to 0 as the potential is constant. So its value is nor increasing nor decreasing. Putting this value in the equation, E is equal to minus delta V over delta R. As delta V is equal to 0, so E is equal to minus 0 over delta R. This 0 makes the whole term as 0, so E is equal to 0. The value of electric field is equal to 0 if the change in potential is 0, means if the potential is constant. So E, the electric field, is 0 in the given region where potential is constant. This shows that if potential is constant throughout a given region of space, then the electric field is 0 in that region.